Day 2. I think anytime a topic has day 2, that's the day to sit up and listen, because things might get out of hand, and they will get out of hand here. Just to be clear, I hope that you went home and practiced enough substitution that you're like, I get the gist of it, okay? Didn't complete your homework? Well, that's homework check, Mr. Todd, that will appear later. He'll deal with that. For the purposes of my lesson, I hope you know this much about substitution, and I'll go back to Friday's lesson. Was it Friday we did this? Yeah, I think so. And here's what we did. We numbered the two equations. We isolated either x or y. We get to choose. That might have felt weird. We get to choose x or y. We isolated one of the variables. We subbed it into the other equation. Then we checked our equation solving skills, because we had to be able to solve equations good. But the good news was, what was the good news when that happened? Do you remember what the great news was once we subbed into the second equation, or into the other equation? We were down to one variable, and that was a major breakthrough. This very difficult situation got reduced to something much simpler. Then we had to test our equation solving skills. That's why the practice was so important, to make sure that you're good at solving for x in that situation. And if you weren't, no problem. That's what the practice was for. Then once you had x, you were home free. Most people at that moment are like, okay, I can do the rest of it. Sub it into one of the equations to get y. That's pretty straightforward. And then check the equations. That's what you need to know to start this lesson. If you walked away and you drifted through that lesson, did no homework, why, some of this might be a little wild, okay? Because today's day 2. It's the same learning goal as Friday. Solve a system of linear equations using an algebraic strategy. And I'm going to add one word to that. I hope you add this word too. Solve a tough system of linear equations using an algebraic strategy. That's good to know at the start of that lesson. So it's good to acknowledge this is going to be tough. So then when you find it tough, you don't have a confidence issue. You don't get all upset and like, maybe I'm not supposed to be in grade 10 academic math. No. Tough is okay. Some things are going to be tough. So recall, the solution to a linear system is a point when both satisfies both equations. Given two linear relations, the ordered pair xy is the point of intersection. That's what we saw when we graphed them. When given any system, we're looking for a variable that has a coefficient of 1. That was the big thing yesterday. And if you're really paying attention, you must be like, he's really rigged these up nice. There's always one of them that has coefficient 1. Isn't that kind? Well, that's why it was day 1. Day 2, here we go. Someone raises their hand. What if there's none with coefficient 1? Well, then you better do some thinking about what you're up against here. Some careful thinking. So I look at this one, I go 4x plus 16y equals 8. If I solve this, and I'm going to do both so you can see. If I try to solve this equation for either x or y, there could be trouble looming. I'm going to do both. I'm going to go after x and y, and then we're going to together come up with a good idea about which one we should go after. Okay? If I decide to isolate y, that's what I could do. Then I would move the x over, and this is the part where if you didn't do your homework, maybe you're not very good at this, and that's really scary in math when you show up the next day and you haven't done enough of the homework to understand the next lesson. That's when things begin to snowball out of control. Do you know what I mean by snowball out of control? All the cartoons when I was a kid, things always snowballed out of control. At the top of the hill, a snowball would start rolling down the hill, and by the bottom of the mountain, it was so big that it ran all over all the cartoon characters. Maybe your TV shows are more advanced than that, but that's the way so many shows ended. It was always a snowball running down the hill. But things can snowball out of control in math classes, even if you're really smart, if you don't keep up. Anyways, then divide by 16. Maybe you're not intimidated. But the F word has come to math class. Not the F word you're snickering about. What F word has appeared here? Fractions. stuck with fractions. And if your fractions are good, you're like, okay, no problem. It's going to take a little longer, but I'm pretty good at fractions. Yes, we need to get pretty good at fractions. I don't intend to torture you with them, but we have to pay attention to them. They're not going to go away. So that was bad. Maybe you think the solution is to isolate x and go, okay, well, when that happens, I'll isolate x instead. And we'll look for somebody for a shortcut in a minute to go, how will I know beforehand which one's got the best chance? So here we go. I'll isolate x instead. 4x equals 8 minus 16y. X equals 8 minus 16y over 4. This is the moment in substitution questions where you're like, come on, divide evenly, make my life easy. What's 8 divided by 4? 2. Oh, you are happy. 2. What's 16 divided by 4? 4. Oh, that worked out pretty well. Now I have lots to tell you. It doesn't have to go well. Both could go badly. But if we're going to avoid fractions, we need to go after the variable. Ooh, which of the two variables should we go after? Which one has the best chance in general? In this example, x was the better one. But if the coefficients had been 16 on the x and 4 on the y, then x wouldn't have been the better one. So we need a general idea. And by idea, I go, it's not always going to work. But just to give ourselves the best chance at avoiding this fraction mess, what should I go after? The smaller one probably has the better chance. But not always. It's a little deeper than that. Here's what you have to do. You look and go, somewhere along the way, if I'm isolating y, I'm going to have to divide by 16. That's part of going to be isolating y. And somewhere along the way, I'm going to have to take this 4 and divide by 4. And probably the smaller one has the best chance. She's right. But you can peek a little bit before you even start and go, how's this going to work out? Is dividing by 16 going to go well? No, I can see it's not going to go well. Is dividing by 4 going to go well? I can see before I even start this procedure. So yes, the small one is the indicator, but also take a look what you're going to be dividing by eventually and see if there's good news on the horizon. This example implies that there'll always be good news on the horizon, and that is not true either. But at least let's look for some good news before we start this when things are tough. Okay? Most of my speech is over. Now I'm going to reteach Friday's lesson with just a little thinking at the start about what to isolate to give myself the best chance. Do you need more time there? Oh, under divide by 4, I'm going to put a check mark. So if you're looking back at your notes to understand why I did that, I like the idea of dividing by 4. That's not going to go too badly. Dividing by 16, only if I have to. Please don't make me divide by 16. Again, those of you who are good with fractions are like, I don't care what happens here. I'll do the fractions. No problem. And that's a strength that maybe you want to build and go, well, maybe I'll do some questions and do the tough fraction version just to make sure my fractions are strong, because eventually we're going to have to do it. All right. Let's get to it. Opening example over. Solve the linear system by substitution. When this happens, you'll immediately look and go, okay, is there any x's and y's by themselves? 2x? No. 3y? No. 2x? No. Negative 2y? No. So it's a level 2 substitution question. We don't call it that. That's Mr. Todd's little catchphrase. It's a level 2. It's like, okay, got to do a little thinking here. Will dividing the first equation, I just look at the coefficients, and that x has got a 2 out there. Will dividing that equation by 2, will that go well? Dividing 3 by 2, well, that's not bad. It's halves, right? If I had to, I'm not too worried about that. Dividing by 2. Dividing negative 6 by 2, that will go well. That might be okay. Will dividing the first equation by 3 be good? No. 2/3? Oh, I don't know if you've ever thought about it. But the difference between doing with halves and thirds, it's just the biggest difference in the world. If thirds hadn't come along, we might not have used fractions. We might have just gone with decimals. Halves are nice. Quarters are actually nice. fifths are nice. It's thirds. Whenever thirds are around, you're like, oh, here we go, thirds. And then it gets out of hand after that. Sixths and sevenths, ninths, none of that stuff goes well. Okay? Those are ugly decimals. So I definitely don't want to divide by 3, unless 3 is going to work really good, which it's not. There's a 2 out there. Let's look at the second equation. Is dividing the second equation by 2 going to go well? Is dividing 2 by 2 going to go well? That is going to go well. Is dividing 14 by 2 going to? Yeah, that's going to go well as well. So this is, I'll just call this a level 2 question. It's like, if you think it through before you start, there is one to seek out where maybe fractions can be avoided. So now I follow the steps. Label these as 1 and 2. And I'm going to write specifically what I'm up to so you can see. Solve equation 2 for x. That's just another way of saying isolate x. So I'm going to rewrite the equation. Maybe you don't have to in your homework. You can skip a couple of steps. You can't just write down the answers here, folks. If you've got your all ready for your homework check and you just write the answers out of the back, no, that's not my first day doing this job. I know you have to show some steps here. Now, move that 2y over. I hope that's good. I hope you did enough homework. You're like, yeah, okay. Subtract 2y. When I move it to the other side is add 2y. Then divide by 2. See, this is what I was talking about, the prediction at the start. I know at some point, if I'm solving for x, I'm going to have to divide by 2. Now, will that 2 go well? Does it ever go well here? Look at this. I'm going to put a box around that. Isn't that what I talked about on Friday? Once you've isolated x, put a box around it for your own sake so you can find this. And this gets a giant smiley face. Aren't I happy? I'm not just happy because there's no fractions. I'm also happy because I thought it out before I started. I didn't blindly run in here, and I looked for one that would come out nice. Does anyone know the fancy next sentence to do once I've isolated x? Yes? Yeah, sub x equals 7 plus y. And if you've got a shorter way to write this, that's okay. I'm not going to hammer your little steps. That's not what I'm about. But I better see some steps in your homework. Sub x plus 7y into which one? 1. See, that's why this labeling is so important. I said solve equation 2 for x. It is about communication, yes. But it's also about me keeping track of what's going on. So now I solve x plus 7y into equation 1. So I write 2x plus 3, whoops, my plus sign. And maybe you're not writing the whole equation out first. Maybe you're subbing right in because you're just that good. I like that, but I'm going to actually write it now. I'm going to go 2 times 7 plus y equals plus 3y equals negative 6. And I'm going to ask again, because this is one of the big ideas of substitution, what is it that makes me so happy at this moment in this solution? Why am I like, yeah, math's awesome, it's so good? Down to one variable. See, and this is a very, very big idea in mathematics. If you have 2 equations with 2 unknowns, there might be a way to combine the 2 equations and make one equation in one unknown, which we feel like we're pretty good at. We can isolate this y. First, get rid of the brackets. Combine like terms whenever possible. Then bring that 14 over, and when it comes over, instead of adding 14, it's now subtract 14. And then divide by 5. Now, those steps I did pretty fast on purpose. Not to torture you, no, just to go, this is why we do the homework, is so that when I get to this part of the lesson, you're like, yeah, I got that. I did a bunch of those. Good. That part I can handle. And it allows your brain to focus on the new or the tough parts of the lesson. That's something that might not have been even explained carefully enough to you in previous grades. The reason to do the homework is so that those parts are now easy for you, and then you can follow the rest of the lesson. Getting rid of all my paraphernalia here. I like boxing that too, me personally. I go, yeah, there we go. I'm going to be looking for that in just a minute. I'm going to be, when I go to state my answer, I'm going to be looking for that. So what's the final move? No, sorry, what's the final move in solving? Not the final move in the question. I've got the y.
You summoned it equation 3?
Yeah, good. I like calling this equation 3. Just nice and organized. And I hope that when you did your homework, and I know I'm preaching on this, that the first time you did an exam, you're like, I forget, what did he do there? And you had to look at my answers. The second time you did it, what did he do there? You look on my notes, you go, oh, yeah, okay. And then the third or the fourth or the fifth. Somewhere along the way, you're like, okay, I'm remembering these steps now. That's how we learn to do mathematics. Yes, partially with a great teacher, hopefully. And then partially like, okay, now give me the basketball. Let me take a few shots here. Ooh, set that foot. Ooh, whatever your little guidelines are. So let me do the sentence here that he suggested. Sub y equals -4 into, and he called it equation 3. And if you call it equation 3 every time, it'll build into you. You're like, I remember what to do next. So I get x equals 7 plus -4, or 7 minus 4. X equals 3, and I like boxing that too. And I've run out of space to do my check. I just want to tell you about something, and I don't want you to go home and tell your mommy and daddy that I told you to buy an iPad, because I'm not going to do that. But I'm going to tell you that I think my AP Advanced Functions class is up to about 40%. When I look out, about 40% of the people are using an iPad. They love doing the notes and the homework all in one thing, carry it from class to class, and it's all there set up at once. And they can do stuff like this. Watch what I'm going to do here. Like, ooh, I ran out of space. So they just reach out and they just grab everything. Their iPad's better than mine. Mine's okay at this, but not great. And they go, I'll just get a little space here. Yeah. My crazy son used to take the whole lesson and go, whoop, put it up here in the corner of one sheet and label it. And then when he needed to see it, he'd zoom in on it and pull it back down. You know, he had a whole crazy system. But good fun, good entertainment. Anyways, I made room because there's more than just the last statement here. What will you like to do next? What's that? Oh yeah, no, that's last. Maybe, actually, I don't know. Maybe you do the therefore statement first, and then you do the other thing afterwards. But anyways, therefore, the solution is, I'm going to state it as a point, but it is okay to state it as, therefore, the solution is x equals 3 and y equals -4. What did I skip that you should do on the quiz? For your own sake. Check, yeah. Check every question in the homework? I don't know. There's a lot of homework, right? There's a lot to do. Maybe you're just going to check the back of the book to double check. But at least every once in a while, go, okay, do I know how to check this? Okay, equation 1. Left side, right side. Did I leave enough space here? 2x plus 3y -6. That's 2 times 3 plus 3 times -4. That's 6 minus 12, -6. Oh, good. Equation 2. Left side, right side. 2x minus 2y. And that's supposed to come out to 14. So that's 2 times 3 minus 2 times -4 is 6 plus 8 is 14. Ah, yes. So happy. Is it possible it works on one of the points but not on the other? Yeah, you got to check both lines. It is possible to make a mistake in the algebra, find an answer that works for one of the equations, but doesn't work for the other equation. So if you really want to check both. Any questions about that? If you're caught up and you did a bunch of the homework or all the homework, the only thing I've taught so far today is take a look when there's coefficients and see which one to solve for that might work out nicely. And if that's boring to you, I'm glad. You should be happy. There's lots of tough lessons coming in this course, so the boring ones we'll take. We'll be very happy to see them. If you're behind, you better get in it. This chapter gets out of hand if you're behind. More time there? I think there's just 2 more examples to go, isn't there? There's a little bit crazier, and then a lot crazier, just in case you just believe this is just the easiest stuff you've ever seen in your life. Okay? 2b plus 10c equals negative 6. 3b minus 7c equals 17. Take a second. Take a moment to look at that and really study it and make a decision about which variable to solve for in which equation. There is some super bad choices. There's one so-so choice and one excellent choice. But I will wait, giving you time to think. You already did it. You're like, I see it. Oh, you didn't see it. You beat it. But you saw. You seed that you could be it. Yes.
First one's easier.
I'll label them 1 and 2. Give you another few seconds. Take this time. Don't wait around till tonight to find out you don't know what's going on. How's my circles? Woo. Which equation, which variable? Who's ready? Equation 1. Which variable? B. She says B. Someone else, she's correct, someone else explain why that is not, why, W-H-Y, why that's such a good choice. The smallest coefficient has the best chance. That's a good place to start looking. But I think she's done better than that. You did better, and I think you looked at it and you went, I know it's going to be good. How does she know it's going to be good? Peter?
She saw the 2 and knows that the 2 could divide into 10 and 6.
The 10 and the 6 both divide by 2. Will that always be true? No. We might get stuck with fractions, but this is our best chance. So she says, and I'm going to write it a slightly different way than I did last time, so you got other ways to write it, so you understand that there's different ways to say this. I'm going to say isolate whoa. That was fun. That's what I meant to do. Isolate B in 1. And I won't even charge you for it. I'm going to do it for you right here. I'm not even going to charge you. No price for this. It's going to be a freebie. It'll be a freebie. You just let that, thank you. He's acknowledging. To be or not to be, that is the question we're working on. Divide it all by 2, and she was so right. Yeah? You just stop and savor your brilliance at that moment. Like look what's in the second one. 7. 7 is the worst. At least 3s, it's a small number. If you have to deal with a fraction, thirds are a problem, but it's a small number. 7, ooh, here we go. Yeah? And 10's nice, actually, because nice decimals if it has to be. So that wouldn't have been the worst choice. If somebody had said 10, I would have been like, well, it's not the worst. Yeah. But 2b was perfect. -3 minus 5c, similar steps to now. Everything else will be fine. Sub b equals -3 minus 5. Into, not 1. 1 was the one I rearranged, and I can see that because I wrote it down. Into 2. And so -3b minus 7c equals 17. Again, you don't have to rewrite the equation there if you've gotten so good at those. But if you're having trouble with these, write the equation first, then carefully where you see b, write your new expression for b. Really is astounding, brilliant mathematics. You might be getting so good at it that you've lost track of how brilliant this is. The rest is the same. Watch out for your negatives, of course, but the rest is the same. I get 9 plus 15c minus 7c equals 17. I get 8c and then I got to move this over. 17 minus 9. 8c equals 8. Well, didn't that work out nice? It doesn't have to. Maybe it'll come out to be a fraction, and you have to sub a fraction back in. That can happen. C equals 1. Then sub C equals 1 into... Technically, friends, you could sub it into 1 or 2. They'll all give the same answer, or else math is broken, or you've made a mistake. So I could use 1 or 2, but isn't this one set up nice? It's like, you want B? Oh, you wanted B. Oh, I can do that. Look how easy it is for this one. Those ones, there'd be a little bit more work to it. So often that third equation is the one to use. B equals negative 3 minus 5 times 1. I get negative 8. And just because I want to keep hammering away on that, I'll show you a different way to check, just like I did on Friday. I'll go to my Desmos, which if you haven't downloaded it on your phone yet, we're going to do lots more graphing. Lots more graphing. So I encourage you to get it because it's going to help you. What happened? It didn't go. Desmos. There we go. Graphing calculator. You can get it on your phone. First equation was 2b plus 10c equals negative 6. 2x. Desmos doesn't like b's and c's. You're going to have to make it into x's and y. So 2x plus 10y equals negative 6. And the second equation was negative 3x minus 7y equals 17. And they met up at negative 8 comma 1. Is that what I got? Negative 8 comma 1. I did get that. Okay? Back to here for Desmos real quick. Desmos does not need you to rearrange it into y equals mx plus b, but it does need you to use x and y. So you're going to have to decide. My b's are going to be x's, my c's are going to be y's, and then you can check the answer that way. Do that at least on every couple of homework, or every few, to go, do I know how to graph this on Desmos? And because I did it on Desmos, I'll answer the question slightly different. Therefore, the point of intersection is negative 8 comma 1. Is it okay? Question. You can decide for yourself, but I usually, whatever they give first, B, I make that the x, and C, I make the y. Now, if someone made the other choice, then they would have got answer, point of intersection 1 comma negative 8, but they still would have said that the B is negative 8 and the C is 1. They just would have had it on different axes. Begs the question, do we really care what axis goes which way? And the only reason we actually care is so we all do it the same. It doesn't actually change the answers you're going to get. Okay? So that upsets the science teachers very much, by the way. They want independent, dependent, and there's reasons for that. In scientific research, we better do it all the same or we're going to confuse each other. But in math, we're like, it doesn't matter. You're going to get the same answers as long as you know what you're doing. But math people are arrogant like that. They just think, oh, it'll all be fine. Sometimes it won't be fine. You know? So, good question. Other questions? Well, I don't want to leave this section with you believing that everything is nice all the time, that if I think it through, it's all going to be good, because it's not all going to be good all the time. So we better look at one where it's very bad all the time. But I have some survival techniques. This question, I know a weapon that makes it so I am not scared of these fractions at all. Might there be fractions in this question? I actually don't know. I don't know from looking at it. Like I might know because I'm the teacher and maybe I've seen this lesson before. That's not what I mean. What I mean is if you just handed me a question like this, I can't just look at it and go, ooh, there's fractions in the answers. I do know when there's fractions in an equation, I am not scared at all. And I need to give you the weapon. It's come up before, but I want to make sure you're very clear on the weapon I have, that you should have, that makes it so fractions and equations do not scare me, not even a little bit. It'll be the best possible weapon that you can play Fortnite with. Okay, hang on. Is Fortnite still a thing?
Yeah.
Or is that old now? So what's the best weapon on Fortnite?
All of the thunder pump.
The Thunder Pump. I keep thinking Legendary Scar. Is that a weapon in Fortnite? What's that? What did you? It's not even a game anymore. It's not even a popular thing. Do you know what a lightsaber is?
Yeah.
All right. I gotta have some reference that everybody can go. I think I saw something about lightsabers once. I need to give you a lightsaber on these because I heard someone groan. I saw someone's eyes roll at this. As soon as they saw it, they're like, oh, here we go. No. It might be bad, but not for this reason. I know the magic number to multiply equation 1 by that is going to make this a whole lot better. Do you know the magic number?
No.
It's not, yeah, 0 completely turns it all into 0 and we get nowhere. There is a magic number that will get rid of all these denominators. It's 12. Where do you get the 12 from? The common denominator. The common denominator is your thunder. It's your lightsaber. It's like, oh, it's okay. It's going to be okay. Slice right through this. But you have to know how to use it, okay? I'm going to multiply equation 1 by 12. I'm going to multiply everything by 12. Always allowed to do that to equations. You can always multiply by whatever you want. I'm choosing 12. Now, I'm going to do it very quickly, and I hope there's a question so I can explain a little better. But multiplying by 12, I know, and I'm trying to teach you, multiplying all this stuff by 12 is really easy. I'm going to multiply the first one by 12, and I get 12x over 4. I'm going to multiply the second term by 12, and I get 12y over 3. And I'm going to multiply 13 by 12, and I get 156. But I hope there's complaints there. What's the complaint?
Why don't you divide the bottom numbers?
Oh, I'm going to. I thought you were going to ask, why didn't I multiply the bottom numbers by 12? Is that what you mean? Yeah. Because if I'm multiplying with fractions, this 12, and I'm going to write it in a different color, when I'm multiplying by fractions, it's actually 12 over 1. Whenever we're multiplying by fractions, 12 becomes 12 over 1. So I'm multiplying the tops by 12 and the bottoms by 1. That's how we multiply by 12. Oh, it's good, right? The more you think about this, the more powerful this weapon becomes. Yes? Just like a lightsaber. The longer you play with it, the more you're like, wait, I can block blasters with this? Wait, I can open doors with this? It's powerhouse mathematics, just going multiply everything by 12. But it could be you're following this along and go, yo, T, that's not better. There's just 12s everywhere now. And maybe you text me tonight and go, so I multiplied by 12, and you give me an attitude-y Judy text saying, so I multiplied by 12, it's not better, Mr. Todd. And I just text back, look again. What is 12 divided by 4? What's 12 divided by 3? Tell me you're not happy at that moment. I've taken that equation that had fractions in it, and I built it into a new equation that has no fractions in it, and I'm going to call that equation 3, because I'm calling that equation 2. You're like, don't call it 3. I want to call it 3 later. That's what I like doing. I'm like, you'll call it 5. You'll be all right. It'll be okay. Now in another color, tell me. What's the magic number for equation 2? 15. Take the common denominator and multiply everything in equation 2 by 15. You try it now. Don't wait till tonight to find out you don't know what you're doing. Try multiplying equation 2 by 15 and let the magic happen. Tell me a Harry Potter spell. Something Levioso? And that's what you're doing right here. Engardu Levioso. Multiply by 15. I'll do it slowly, so you can look up to check your answers as you go. How'd it go? Is it okay? Fabulous. From here till the end of calculus, that trick will serve you well to go, if I got an equation with crazy fractions, multiply through by the common denominator, and I'll get better equations. Now, problem's not solved. Story's not over yet. I'm going to go up here, I'm going to rewrite the two equations, and now go back to my original thinking. Here's equation 3. Here's equation 4. We just double check that I copied them right. 3x plus 4y equals 156, 10x minus 12y equals 45. Now, are there any x's and y's that don't have a coefficient? No. So it's at least a level 2. What's dividing by 3 going to do in the first equation? Nothing good is going to come of that move. Dividing by 4? No good. 3 divided by 4, not something nice. Second one, divide by 10? Not good. Divide by 12? No good. And you can be mad at that point. You're like, Mr. Todd, why would you make an equation like this? Well, the world doesn't care how much you like equations or not. When you build real world problems, real word problems, both, the numbers are going to come out to what the numbers are. So then we need somebody to make a decision for us. Of all of those choices, 3, 4, 10, and 12, what would you prefer to divide by if you absolutely had to? Destiny. She's not scared of 3. She likes 3 because it's the smallest number. She says it goes into 156, and I'll deal with the fact that this is 4/3. I love her answer. It's a great answer. And if you're going to deal with fractions, you may as well deal with the smallest number. That's a good answer. Who's got a different answer? Because there's choices here, and I don't know that there's one that's better than the other. Everyone got a different choice? Good. I'm going to do 3 then. That's what we're going to do. Now, fair warning. Some people might like 4 better because the decimals of 4 are more friendly. Maybe. Or 10 because the decimals of 10 are very friendly. Well, let's stick to fractions. Let's be fraction people. Let's practice our fractions. So, isolate x in equation 3. Same steps, but I know what's coming. Fractions are coming. 3x plus 4y equals 156. Bring the 4y over, and then divide it all by 3. When I divide those by 3, 156 divided by 3 is 52, as she predicted. That divides by 3. So at least that term's not a fraction. However, this one is a fraction. To which you say, okay, it's okay. Same steps, it's just I got to be ready for fractions. And now I'll slow things down because those steps are very similar in there. I'm even going to go to a fresh page, so I'll have to go back and forth from it. Oh, do I have my page switcher? I don't have my page switcher. Here it is. Now I broke my page switcher. Stupid gravity. I'll give you time for this because we're almost done. Oh, I should act like I'm using the force, right? Watch this. Yeah? Whoa, you want to go back? Doesn't it look like I'm using the force there? It's every magic trick in history. You were looking here, the magic was over here. Yeah? Are you okay? You're a little upset, but don't worry. So now I'm going to sub x equals 52 minus 4/3 y into, ooh, I'm getting confused now. I rearranged 3, so I'm going to sub it into 4. Is it okay? Into 4, which I will copy. So equation 4 was 10x minus 12y. 10x minus 12y equals 45. I'll let you stare at that for a second. So you can see that it's the same thing that I've been doing. But there's some scariness here. When I multiply out the brackets, I get 520. That's okay. And I think this is easy. But I'm old. Yes? When I multiply 10 by 4/3, you may need to do this and go put that over 1 to remind yourself, if I'm multiplying by fractions, I'm multiplying the top by 10, but the bottom by 1. The numerator by 10, but the denominator by 1. Just to warn you, we stepped right to the very edge of this course here. This course doesn't, you're not going to go to your homework and have 17 of these like this. This is just us going, can we handle very tough situations? And yeah, the procedure handles the tough situations. Do we have a lightsaber expert to save us from these fractions now, though? I mean, you could collect like terms here. You could do that. But there's an easier way. What's the easier way? Multiply it all by the common denominator. What is the common denominator? No, common denominator. There's only one. 3. Yeah, the common denominator is not too complicated. And if you want a fast way to write that, this is the way I do it. Different teachers do it differently. I just go, wait a minute, hold on. Let me just lightsaber this thing and get rid of the fractions. I'm going to multiply everything by 3. So I get 1560. Minus 120 over 3y. Minus 36y equals 135. You double check that, okay? I don't want to do it too fast for you. Carefully punch those each in and see if you get the same as me.
Yeah, wouldn't it just be 120?
What's that?
Wouldn't it just be 120 since we multiplied it divided by 3?
Oh, well, it's actually just going to be 40 when I'm done. Because that 3 and that 3 are going to cancel. It's actually going to be 40. You could get good enough at it that you skip that step. Are you with me or no? Are we saying different things? See, the 10 only multiplied in the brackets. The 3 multiplied by everything. Is it okay? I want to give you time. Look that over. I'm just getting Desmos ready. So you look that over and see if you agree. I'm not looking at your stuff. I'm actually just stealing your equations initially. Equals 3. X equals 27. Y equals 18 3/4. Let me show the other steps, and then I'll pause for questions. Can we just pause for a second and be clear about what I'm trying to accomplish here? So you're not confused about what this example is trying to do. Am I trying to turn your math world upside down in one example? No. I'm actually not trying to do that. I'm trying to go, this procedure works for crazy numbers. Second, we may have to continue to improve on our ability to deal with fractions if we're going to continue on in math. Right now, a little bit. We got to keep pressing on fractions to be able to handle these situations. In the final answer, I wrote down the fractions. I also wrote down the decimals. Okay? Come test time, we need to establish, am I going to accept decimal answers or am I going to accept fraction answers? I'm not going to really give that away yet. I encourage you to keep working on your fractions. I don't want to give you freedom just to go to decimals yet. To explain the whole decimal situation, I guarantee as we build iPhones, try to send missions to Mars, build nuclear power plants, that people aren't just rounding to decimals all the time. They have to keep the exact answer and work with the fractions. That's why we keep working with it. Sometimes we need exact answers. We can't just round. Now this one was nice because it was a nice decimal. Okay? This question ends up by going sub y equals 18.75 into 5. And since we've already gone to decimals anyways, I'll finish it off with decimals just to try to reduce your fear a little bit about this mess. I'll type that in, 52 minus 4/3 of 18.75. And I think actually it comes out to something reasonable. Yeah, 27. Therefore, the solution is 27, 18.75. I encourage you to take the original equation and plug it into Desmos and see if you get 27, 18.75. Because that's really fun and scary. Yeah. But is there any questions about that algebra? Because it's really scary. It's not being nice. Like grade 9 sort of We'll just keep the numbers nice all the time. Day 1 of substitution is like, oh, here's some really nice numbers. Day 2 is like, well, we better start experimenting with tough numbers. If we're going to get used to real world type questions, we better fight the tough numbers once in a while. Okay? What questions do you have? That's a great question. I'm going to answer that in a second because I want to talk about lesson D2L test, the whole thing. Yeah.
Is there a day 3?
There's not day 3 of substitution. Now we switch to a new method called elimination, which actually would do this question in a much easier way. And then we'll do day 2 of elimination.
Is it a different method for the same equation?
Yeah.
Oh, so like on a test or something, you give us that equation, we can use either method?
Yes. By the end of tomorrow, no, sorry, by the end of Thursday, it's possible you'll be a little angry going, why did you do that with substitution? Elimination's way better for that one. But we're slowly building our understanding to be able to go, oh, for this one, because there's already an x by itself, substitution would be great. For this one, when x doesn't go nicely by itself, maybe we'll try elimination. You know, so we're building up to that kind of wisdom. Yeah, it's good? Questions here? In the meantime, I'm using this to work on your fractions a little bit because that's going to need work as we go, no matter how good you are at them.